Jai Hind everybody. So I'm Neeti Pahuja and providing you with a lecture on the topic input output organization. The topic is from the subject computer organization and architecture. Since we know according to the Flynn's classification that any computer system, it is comprising of multiple components. So one of the major component of any computer system through which the user interacts is input output organization. So anything that through which we can provide the inputs to the computer or through which we can accept the output from the computer is known as the input output organization. So these are the contents through which I'll cover the complete topic of input output organization. For today, we'll start with peripheral devices. So input and output devices attached to the computer system are called peripheral. So any device which is externally connected to the system is called an input or output device or the peripheral device. So majorly, we have three types of peripheral devices: input peripherals, through which the user can provide the inputs; output peripherals, through which the user can get the outputs, that is monitor, printer, etc., and input output mixed peripherals. For example, the touch screen, we can get the output through it and we can provide the input through it as well. So the speed through which the user interacts with the system, through which the user inputs to the system, is entirely different from the processing speed of the computer, processing speed of the processor. So we need to have something in between that can provide us the synchronization between the input output peripheral and the central processor. So we have a interface. What this interface is a very important thing that provides us with a communication medium or maybe a tool to provide the interaction between the input output peripheral and the processor. So it provides us a method for transferring information between internal storage and external IO devices. Why we need this interface is an important thing to consider. So there are a number of differences between the central computer and each peripheral. They are entirely different in their mode of operation. The differences may be because peripherals are electromagnetic and electromechanical devices, whereas the memory and the CPU are electronic devices. So the way they handle the data is entirely different. The way they save the data, they need to be connected. So there is a need of a data conversion through which they can interact. And the interface provides us with that conversion through which they can interact. The data transfer rate of peripheral, it is usually slower than the rate of CPU. For example, if we take the example of a keyboard, the user provides the input through the keyboard. The writing speed, the typing speed of a particular person is normally 10 to 20 characters per second. But the processing speed of the CPU is 1000 instructions per nanosecond maybe. So we need a synchronization, a speed matching between the two devices, and this is provided by the input-output interface. Next difference is the data codes and formats in peripheral differ from the word format in CPU and the main memory. Definitely, whenever I speak, it is not always the case that this other person's understand the same thing. So we need a data conversion method, data format conversion. Like if I speak in German, if I go to Germany and then I go there and talk in English, they may not understand English or Hindi. So I need a person to convert my language into Germany and then German language into my language. So this is provided by this interface. The last difference will be operating mode of peripherals are different from each other. If we have a number of peripherals connected in the system, their operating modes are different. So we want a system so that all the peripheral devices can connect to each other and they can work independent of each other. So that is why we need an input-output interface. So to resolve the differences, the computer system include a special hardware component between the CPU and peripheral. This interface can be a hardware unit or it can be a software unit or it can be a mix of both. For example, if we take the example of a printer. Printer is an output peripheral which is connected externally to the computer system and through which we can get the output. So whenever we insert the printer to the system, we need to install particular drivers for that. The driver software is a software interface for connecting the CPU with the printer. So that is an example interface. These components are called the interface unit. This driver software is an interface unit because they interface between the processor and the peripheral device. For example, if I have my CPU here and I have a IO device, the IO device cannot be directly connected to the CPU. We need to provide an interface, IO interface between the two devices so that they can easily communicate with each other. This is an example. We know that the CPU, memory, and all the devices, all the systems, all the devices in the computer system are connected through the system buses. And in system bus, we have three types of buses: address bus, data bus, and control bus, over which we can send the data, we can send the control signal, and the address information can also be exchanged through these buses. So any peripheral device that is needed to be connected to the buses has to go through an interface. The device will send its data to interface. Interface will check whether the data is needed in which format the data is needed by the CPU or the memory, and it is the responsibility of the interface that it will change the data in the accordance manner, and then it will transfer the data to the CPU. For this, the interface has multiple type of registers, or we can say this multiple type of buffers. It has data buffer, it has address buffer, through in which they place the data when they get from the device or from the CPU, convert this data, and then this data is adapted by the particular device. So the main function of IO interface are data conversion. As I have already told you, we can have analog data or digital data. If one device is using analog signal and the other is using the digital signal, we need to translate the signals in a single format so that both can communicate. Or the serial and parallel data may be there, so they have to be aligned in one way so that they can be transmitted. Second thing is the need is synchronization. Synchronization is always concerned about the speed of data transfer. So when there is a speed mismatch between the devices, we need an interface so that it can provide us with the synchronization in their speed. Third thing is the device selection. Out of many devices, we can have n number of input-output peripherals connected to a CPU. So whenever the CPU wants to connect to a particular device, it needs to it needs to select this device to let it know that you are the one to which I am communicating. So this device selection is also provided by this interface. It is the responsibility of this interface to let the device know that you are the one to whom the CPU is connecting now. The interfaces provide the functionality through these IO commands. We have four major commands. First is the control command. As I already discussed, it is used to activate the peripheral and to inform it what to do. For example, if I have a computer system, my central computer system, and through which I have connected my keyboard and mouse and printer and many other devices, I have already connected to it. Now, whenever CPU wants to send some data, the data will go to the keyboard and to the mouse and to the printer. So every device needs to check whether the data is for me or for another device. So that it is the responsibility of the interface. It will tell a particular device, okay, this data is for you. Now, or maybe for the keyboard. Now, keyboard can have a number of keys. Which key to press, it is also told by the interface through this control command. It activates a particular peripheral device and tells it what to do. A peripheral device may have a number of functions. For example, in a mouse, we can have right click, we can have left click, we can have scroll. So which function is needed to be performed, that is told by the interface. So each device has its own sequence of control commands depending on its mode of operation. Second command is the status command. Status command is used to check various status condition. For example, if a particular device is available or not, if it is ready to perform the function or not, or it can be used in error checking as well. Sometimes we need to send the data and then also need to confirm whether the data that has been received, it is correct or not. So that correction bits, or maybe called the parity bits, those are checked by this status command of the IO interface. Next is the output data command. It is important. It causes the interface to respond by transferring data from the bus into one of its register. When CPU sends the data to a particular IO device, the interface through this output data command transfers the data from the bus. CPU and the device, they are connected through the system bus, as I have already explained in the earlier figure, that the CPU and the devices are connected through the bus and through the interface. So whenever CPU puts some data on this data bus, the interface will copy this data in its buffer register and then it will send the data to a particular device. So this output data command actually causes that. It causes the interface to respond by transferring data from bus into its register. We have multiple registers, as I've already told. So it will save the data in the data register. And when the device, this is an IO device, when the device needs to send some data, it will send it to interface, and then through the input data command, the interface will put this data over the data bus. So interface receives an item of data from the peripheral device. This interface, it will receive the item of data from this peripheral device and then places this data in the buffer register, through which it will transfer the data over the bus, over which the CPU will get this data. So now we will see how these IO devices are connected to the memory bus, using the buses. There are various ways the computer buses can be used to communicate with memory and IO. First way is use two separate, like I have this CPU and I have IO devices and memory devices. These are the major components of any computer system. Now we want to see how the IO devices can be connected to the memory devices. We know that the connections has to be through the buses only, the system buses only. So we have three types through which these systems can be, this IO and memory can be connected. Definitely they have to get CPU in between. If they want to transfer the data, we have separate thing for that, which is called DMA, direct memory access, that we will cover later. Right now we are concerned when IO device is connected to memory through the CPU, how they can be connected. For that, we have first notation, that is using two separate buses, one for IO and other for memory. So we'll be having one system bus for IO devices and one system bus for memory device. In this system bus, we are having an address bus, a data bus and a control bus. A data bus and a control bus. So whenever CPU wants to send some data to the IO, it can send the data directly on the IO system bus, and when it wants to access the memory, it can directly send the data over the memory. This system is the most convenient system that we have, but the disadvantage of the system is that we need to have a number of buses. As many IO devices I have, that many number of buses I need to have. So this will increase the cost of my system. So somehow we need to reduce this cost, and this approach is not practically feasible. So the second system that we know is of isolated IO. Isolated IO says that the same thing. We have a CPU, an IO device. We have a CPU, an IO device. Definitely this IO device is connected through the interface to the system. And now we have a memory unit. So according to isolated IO, it says use one common bus for both memory and IO, but have separate control lines for each. That means the system bus, which is having two parts. So the address bus is common Address bus is common and the data bus is also common. So whenever a particular address comes, it will go to IO and to memory as well. Whenever the data comes, it will go to IO and memory as well. But how they will identify whether the data is for me, whether I need to perform something or not? It will be performed using the separate control lines. The control bus will be different for both. There will be separate read-write control for IO and for memory. So if we need to perform the operation from memory, so this particular control line will be activated and memory will get to know from where I need to put the data. When this command is for IO, the read-write signal for IO will be activated and the IO device will get to know, okay, this data is for me or I need to perform this particular function for this address. So since we are having different controls for IO and for memory, this type of organization is referred to as isolated IO. Third thing, with isolated IO, we can have much confusion. To avoid this confusion and to further reduce the cost of the system, we have memory mapped IO. Memory mapped IO says simple. The simplest one is use one common bus for memory and IO with common control lines. Now, we have a CPU, we have IO devices and which are connected through the interface, and we have memory. Now there will be one common bus. In the first organization we saw, we'll be having different buses for IO and for memory. In the second organization, the address bus and the data bus were common, but the control buses were different. In the third organization, we'll be having same bus, same system bus for IO, same data bus for IO and same control bus for IO and memory. Now, how they will differentiate whether a particular address, whether a particular data is for IO or for memory? For this, what we do, for example, let us have 8 addresses in the system. The memory is having 8 cells. Now, the cells will be numbered 0, 1, 2, 3, 4, 5, 6 and 7. So, what do they do? Out of these particular, let's say we have 8 memory locations and 2 IO devices. 2 devices we have, device D1 and device D2. From this particular memory organization, from these 8 organizations, they will reserve some addresses for the IO devices, maybe 2 for D1 and 4 for D2. Out of these memory locations, the addresses will be provided to the devices. So whenever we get the address, whenever there is address 2, the IO device will get, okay, this particular address is for me, now I need to perform the function. When the address is provided on the link, it is 3. The memory will get, okay, I need to perform the address since it is memory address. So out of these memory addresses, some of the addresses are reserved for the IO devices, and that is why it is called as memory mapped IO. The memory addresses are mapped for the IO addresses as well. This is the most efficient approach that we can have. Here we are reducing the bus lines and so reducing the cost of the system. Also, it is the spaces are not wasted. So there is a difference between isolated and memory mapped IO. In isolated IO, we have memory and IO, they have separate address spaces. Remember, as I told in this slide, that IO separate space for IO and separate space for memory. But in memory mapped IO, we have one space which is reserved for memory, and out of those spaces, 1 or 2 or the number of IO devices we have, these many numbers are reserved for the IO devices. So both have the same address space. That is why it is called isolated, where the addresses are different, and it is called memory map because out of the memory addresses we are providing some addresses to the IO devices. So all addresses can be used by the memory in isolated IO because IO address space and memory address space are different. But due to the addition of IO addressable memory, it becomes less for memory. So we were having 8 locations for memory. Out of those we reserved 2 for IO, so we are left with less number of memory locations. Separate instruction control read and write operation in the IO memory. As I already told that IO address bus and the memory bus are same, but the control bus is different for both the devices. Same instructions can control both IO and memory. We are having the same bus in memory mapped IO. In this, IO addresses are called ports. Here, the normal memory addresses are used. It is more efficient due to separate buses. It is less efficient maybe because we are having the same bus for accessing both the devices. It is larger in size due to more buses since we are having separate bus. It is smaller in size since we are having the common bus. It is complex due to separate logic is used for both to control the both thing. Here simple logic is used. Simple logic is used whenever a particular address is for IO, it is the IO will work, and when the address is for memory, the memory will work. So this is isolated versus memory mapped IO. This question is generally asked in the university examination, the difference between isolated versus memory mapped IO. So we have seen a complete difference and the basic of IO versus memory bus. So that is all for this lecture. Next we will continue in the next coming lectures. Thank you.